Before we begin, take a moment to let the ideas settle in front of you. If you enjoy calm, deep explanations about the universe, the brain, and reality itself, consider liking this video and leaving a comment. It tells the algorithm that this kind of thoughtful science matters, and it helps this channel reach people who are genuinely curious about how the universe works. And if you want more long-form explanations like this, you're welcome to subscribe. Now, let's begin. The universe is filled with light. Every star you've ever seen, every galaxy ever photographed, every glow in the night sky, all of it exists because light exists. But light is not permanent. And one day, far beyond any human time scale, the universe will produce its final photon, the last light that will ever exist. To understand how light ends, we first need to understand why light exists at all. Light is not a background feature of reality. It is a process. Stars shine because matter is unstable. Inside stars, atomic nuclei are forced together under enormous pressure. Hydrogen becomes helium. Energy is released. That energy escapes as light. This process only works because stars are burning fuel, and fuel always runs out. Every star in the universe has a lifespan. Some live for millions of years, some live for billions, but none live forever. Even the smallest red dwarfs, the longest living stars we know, will eventually exhaust their fuel. When that happens, they stop shining. Right now, the universe is in what scientists call the stellar era. This is the age of stars. Galaxies glow, nebulae form, new stars are born while old ones die. But this era is temporary, and it is already closer to its end than its beginning. The universe is about 13.8 billion years old. Star formation peaked billions of years ago. Right now, fewer stars are being born than at any time in the past. The universe is slowly running out of the raw material needed to make new light. Gas clouds collapse into stars only when conditions are right. But over time, gas gets used up. It gets locked inside stars. It gets scattered by supernovae. And as the universe expands, matter spreads farther apart. Gravity struggles more and more to pull it back together. Expansion is the key. The universe is not just expanding, it is accelerating. Distant galaxies are moving away from each other faster and faster. Eventually, they will be so far apart that no new stars can form between them. Entire regions of the universe will go dark, isolated, and cold. In the distant future, galaxies will no longer be visible to each other. Each will become an island of fading stars drifting through expanding space. This is not speculation. This is a direct consequence of measured cosmic expansion. As time continues, star formation stops completely. No new stars, no new light sources, only aging remnants. White dwarfs, neutron stars, black holes. These are the leftovers of stellar death. And even they do not shine forever. White dwarfs glow faintly at first. They are hot cores left behind after stars die. But they produce no new energy. They only cool, slowly. Over trillions of years, they fade into black dwarfs, cold, dark, inert. Neutron stars spin. They emit radiation, but they lose energy. Their rotation slows. Their emissions weaken. Eventually, they become silent. Black holes remain. They do not shine in the traditional sense, but even they are not eternal. According to quantum physics, black holes slowly lose mass. This process is called Hawking radiation. It is incredibly weak. So weak that a black hole the size of the sun would take longer than the current age of the universe to noticeably shrink. But over unimaginable time spans, black holes evaporate. And when a black hole evaporates completely, it releases its final energy as radiation, as light. This is one candidate for the last light the universe will ever produce. But black holes are not the only possibility. Some theories suggest that protons themselves may decay. If this is true, then matter is not permanent. Even atoms would eventually fall apart. When they do, they would release tiny bursts of energy, faint flashes, barely detectable, but still light. These would occur long after stars are gone, long after galaxies fade. In a universe almost completely dark, the final light would not illuminate anything. There would be nothing left to see. It would simply exist, and then vanish. What happens after that depends on which theory is correct. Some physicists believe the universe will approach heat death, a state where energy is evenly spread. No gradients, no motion, no usable energy, just cold equilibrium. Others propose more exotic endings. Vacuum decay, a sudden collapse of physical laws, a reset, or a bounce. But none of these involve stars. None involve familiar light. The key truth is this: light depends on difference. Temperature differences, energy differences, motion. And the universe is slowly erasing those differences. The last light will not mark an ending. There will be no observer, no moment, no awareness, just a final physical process completing itself. And yet, right now, light fills the universe. Right now, stars burn. Right now, complexity exists, which makes this moment extraordinarily rare. This is not a story about fear. It is a story about time. And this is only the beginning. To understand what the universe looks like after the last light fades, we need to clarify something important. Darkness is not a thing. Darkness is the absence of light. And in physics, absence behaves very differently than presence. When light disappears, space does not collapse into nothing. Space remains. Time remains. Matter may remain, but interaction changes. Light is how information moves. Without light, nothing observes anything else. Not because objects vanish, but because no signals connect them. This leads to an important question. Does time still exist in a universe without light? According to physics, yes, but not in a way that means anything. Time is measured through change, movement, energy transfer, interaction. Without light or energy gradients, time becomes meaningless. It passes, but nothing records it. In a heat-death universe, time is technically infinite, but functionally frozen. This is one of the strangest truths in cosmology. The universe can exist without events. When the last light fades, the universe does not end. It simply stops happening. This raises another question. Why did light exist at all? Why wasn't the universe dark from the beginning? The answer lies in imbalance. The early universe was not uniform. It had tiny fluctuations, slight differences in density and temperature. Those differences grew. Gravity amplified them. Matter clumped. Stars ignited. Light emerged. Without those initial imperfections, nothing would have formed. No galaxies, no stars, no chemistry, no life. Light is a consequence of asymmetry, and asymmetry never lasts forever. As the universe expands, those differences smooth out. Energy spreads. Temperature equalizes. Structure dissolves. Entropy increases. Entropy is often misunderstood. It is not disorder. It is sameness. A universe full of energy differences can do work. A universe where everything is equal cannot. Light requires work. Work requires difference. As entropy increases, the universe becomes less capable of producing light. This is why heat death is not an explosion or collapse. It is a fading, a leveling. Another theory proposes something even stranger: vacuum decay. According to quantum field theory, empty space is not truly empty. It exists in a specific energy state, but that state may not be permanent. If the vacuum is unstable, it could suddenly shift to a lower energy configuration. If that happens, the laws of physics would change instantly. light, matter, and forces would behave differently or cease entirely. This would travel at the speed of light. You would never see it coming. But this is speculative. Possible, not proven. Another possibility is the Big Rip. If dark energy continues to increase, expansion could accelerate so violently that galaxies tear apart. Then stars, then atoms. Light would end not by fading, but by destruction. However, current measurements suggest dark energy is stable. The Big Rip is unlikely. The most supported scenario remains heat death. A slow dimming, a universe running out of usable energy. This leads to the idea of the last observer. If nothing observes the final light, does it matter? Physics says yes. Observation is not required for existence. Light does not need an audience. But meaning is a different question. Meaning requires minds, and minds require energy, which brings us to a deeper truth. Consciousness exists only during certain cosmic eras. Too early in the universe, there was no structure. Too late, there will be no energy. We live in a narrow window, a brief period where complexity is possible. Stars make heavy elements. Heavy elements make chemistry. Chemistry makes life. Life makes awareness. The last light marks the end of that window. But the fact that it exists at all tells us something extraordinary. The universe is capable of creating moments. Moments where matter becomes aware of itself. Moments where light reflects back on its source. This is not poetic exaggeration. It is a physical fact. Every conscious thought is powered by ancient starlight. As the universe expands, something subtle but profound begins to happen. Distance itself becomes a barrier. Not because space fills with anything, but because space stretches. Galaxies move away from each other faster than light can cross the growing distance between them. This does not violate physics. Space itself is expanding. Eventually, light from distant galaxies will never reach us, not because it fades, but because it is outrun by expansion. From within a future galaxy, the observable universe will appear empty. No cosmic background radiation, no distant galaxies, just local stars slowly dying. To future observers, the universe will look small, isolated, finite. This has an important consequence. Cosmic knowledge disappears. Evidence of the Big Bang fades. Evidence of expansion vanishes. Astronomy becomes archaeology. Future civilizations, if any exist, may conclude the universe is static, eternal, dark. This highlights a strange truth. Understanding the universe depends on timing. We exist at a moment when the universe is visible, when its history is readable, when light still carries information across vast distances. Once that light disappears, the story becomes inaccessible, not destroyed, just unreachable. This leads to another question. Does information survive after the last light? Physics suggests that information is conserved, even if matter decays, even if black holes evaporate. The information is not lost, but conserved does not mean usable. Information without energy cannot be accessed. Without access, it might as well not exist. This distinction matters. The universe may still contain everything it ever was, but nothing can retrieve it. In that sense, the end of light is the end of memory. Another question people ask is whether the universe could restart, whether heat death is truly final. Some theories propose cyclic universes, universes that collapse and rebound. Others propose quantum fluctuations giving rise to new universes. But these ideas remain speculative. There is no evidence that our universe will reset. Current physics suggests a one-way process, from difference to sameness, from structure to uniformity, from light to dark. But even this conclusion comes with uncertainty, because physics itself may change at extreme timescales. Our understanding is based on laws tested within a narrow range. Trillions of years push beyond that range. The universe has surprised us before. Dark energy was unknown a century ago. quantum mechanics was unimaginable. The future may hold unknown physics, unknown processes, unknown forms of energy. But all known models agree on one thing. Starlight does not last forever. Light as we experience it is temporary. This reframes our place in the universe. We are not early. We are not late. We are precisely on time. Complexity is at its peak. Stars exist. Planets exist. Life exists. The last light is unimaginably far away, but cosmically inevitable. And yet, its inevitability does not diminish the present. It enhances it. Scarcity creates value. The universe is valuable because it changes, because it does not last. When people hear the word forever, they imagine an endless stretch of time. But in physics, forever has a different meaning. Forever means no known mechanism for change. After the last light is produced, the universe does not suddenly stop existing. It continues, but it no longer evolves in meaningful ways. In a heat-death universe, particles still move. Quantum fields still fluctuate. Time still advances, but nothing new emerges. This is one of the most difficult ideas to grasp. Motion without progress. Time without events. Existence without history. Darkness in this context is not blackness. It is sameness. Every region of space approaches the same temperature, the same energy density, the same state. Without gradients, nothing flows. Without flow, nothing happens. This raises an important question. Can quantum mechanics ever produce new light in a dead universe? At extremely small scales, quantum fluctuations never stop. Even empty space vibrates. Pairs of particles appear and vanish. Energy briefly emerges and disappears. But these fluctuations do not violate the overall trend. They do not accumulate. They do not build structure. They are noise, not signal. Some theories suggest that over infinite time, rare fluctuations could create complex states again, even entire universes. This idea is known as Boltzmann fluctuations. However, these events would be unimaginably rare, so rare that they are effectively impossible on any meaningful timescale. And even if they occur, they do not reverse heat death. They do not restart the universe. They are isolated anomalies. Another important question is whether darkness feels like anything. The answer is no. Feeling requires observers. Observers require energy. Energy requires gradients. Without light, there is no experience. This means the end of light is not frightening. Fear requires minds. The end of light is simply an absence of perspective. We often project human emotion onto cosmic endings. But the universe does not experience loss. It does not experience silence. It does not experience darkness. Those are human interpretations. From the universe's perspective, nothing is wrong. Processes complete. Equilibrium is reached. This is neither tragic nor hopeful. It is neutral. But from our perspective, it carries meaning, because we exist in contrast to it. The fact that the universe can end in darkness highlights how rare light truly is. Not just starlight, but understanding. Every equation ever written, every idea ever formed, every story ever told, all exist because light allowed complexity to form. Light enables chemistry. Chemistry enables biology. Biology enables awareness. The last light marks the end of that chain, but it also marks its success. The universe achieved complexity. It achieved consciousness, even if only briefly. This leads to one of the deepest questions in cosmology. Was this inevitable or accidental? Did the universe have to produce light, or was it a temporary side effect? Physics cannot yet answer this. Some constants appear finely tuned. Small changes would prevent stars from forming. Others may arise naturally. Whether the universe is designed, random, or necessary remains unknown. What we do know is this: light happened, life happened, Awareness happened, and that is extraordinary. Human beings are uniquely drawn to endings. We imagine the end of days, the end of time, the end of the universe, not because we want things to stop, but because endings help us understand beginnings. When we ask how the universe ends, we are really asking what it is. Cosmic endings reveal the rules that govern everything. They show us what lasts and what does not. Light feels fundamental, but it is not. It is conditional. It exists only when circumstances allow it. This realization can feel unsettling, but it also clarifies something important. Nothing about the universe is guaranteed except change. Even the laws of physics may be temporary. They hold now, they may not hold forever. This uncertainty is not a weakness in science. It is honesty. Science describes what we can test. The far future stretches beyond that. Still, the fact that we can predict the fading of light at all is remarkable. It means the universe is understandable, at least partially. Another question often asked is whether anything we do matters in a universe that ends in darkness. Physics does not answer this question, but understanding physics reframes it. Meaning is not cosmic permanence. Meaning is local impact. Stars do not shine forever, yet they shape everything that comes after them. Light does not last forever, yet it creates complexity. Human actions are the same. They do not need to be eternal to be meaningful. This is not philosophy added onto science. It is a conclusion drawn from it. Cosmic impermanence does not erase significance. It defines it. Another reason these topics hold attention is scale. The universe operates on timescales so large that human concerns shrink. This is not minimizing. It is contextualizing. Context can be calming. When viewed against trillions of years, urgency softens. The mind relaxes, not because problems disappear, but because perspective expands. This is why people find comfort in space. Not because it is gentle, but because it is vast. The last light represents the outer boundary of possibility. Beyond it, nothing changes. Within it, everything happens. Right now exists inside that window. Every thought you are having is powered by energy released billions of years ago. Ancient stars, long dead. Their light became atoms. Those atoms became biology. That biology became awareness. The universe does not know it did this, but it did. And that fact alone gives this era significance. Even with everything we know, the future of the universe is not fully written. There are still unanswered questions, and those questions matter. One of the largest unknowns is dark energy. We know it exists. We can measure its effects, but we do not know what it is. Dark energy drives the expansion of the universe. It determines whether expansion slows, stabilizes, or accelerates. And that determines how light ends. If dark energy remains constant, the universe fades slowly. If it weakens, gravity could eventually slow expansion. If it strengthens, expansion could tear everything apart. Right now, measurements suggest stability, but cosmic measurements are difficult. Small errors matter. Another unknown is proton decay. Some theories predict it, others do not. Experiments have not yet observed it. If protons decay, matter itself dissolves. Atoms fall apart. Light becomes even rarer. If they do not, matter remains indefinitely. Cold, dark, stable, both outcomes still lead to darkness. But the path differs. Another question involves black holes. We believe they evaporate, but Hawking radiation has not been directly observed. It is inferred. If black holes do not evaporate, they remain as the final structures. Massive, silent, eternal. If they do evaporate, their final flashes may be the last significant light events. Either way, starlight ends long before. Another unknown is whether the laws of physics themselves change over time. Constants may not be constant. Dimensions may behave differently at extreme scales. The universe has surprised us repeatedly. We should expect it to surprise us again. But uncertainty does not erase the big picture. It refines it. The universe moves from simplicity to complexity, then back to simplicity. From hot to cold, from dense to diffuse, from bright to dark. This pattern appears everywhere in physics. Stars form, burn, and fade. Galaxies assemble and disperse. Energy concentrates and spreads. The last light is part of that pattern, not an exception. Understanding this does something subtle to the mind. It shifts focus. Instead of asking how to stop the end, we ask how to understand the moment. Science does not promise permanence. It offers clarity. Clarity reduces fear. Fear thrives on uncertainty. The universe may end in darkness, but it began in light, and in between it produced minds capable of understanding both. That is not insignificant. When we talk about the last light in the universe, we are not really talking about darkness. We are talking about limits. Limits give shape to everything that exists. Without limits, nothing stands out. Nothing matters more than anything else. Light matters because it ends. Complexity matters because it is temporary. Awareness matters because it is rare. The universe does not rush toward darkness. It drifts, slowly, patiently, following rules written into its structure from the beginning. There is no countdown, no final moment, no edge where everything suddenly stops. Instead, the universe gradually becomes quieter, not silent in a dramatic sense, but uneventful. And long before that happens, long before the last star fades or the last black hole evaporates, something far more important has already occurred. The universe became aware of itself. For a brief window in cosmic time, matter arranged itself into systems capable of observation, curiosity, and understanding. Systems capable of asking where light comes from and where it goes. That window is now. This does not mean the present is special because it lasts. It is special because it exists at all. Every explanation you've heard in this video depends on light that traveled for billions of years. Every idea you've considered is powered by energy released in ancient stars. Every moment of awareness is part of the same physical story. The last light will not erase that. It does not undo what happened before it. Physics does not measure value by duration. It measures processes by consequence. Stars no longer shine, but they shaped everything that followed. Light no longer travels, but it already carried its information. In that sense, the universe does not forget. It simply stops recording. The fact that we can predict the universe's future at all is evidence of how deeply ordered reality is. Even its ending follows rules. And those rules tell us something quiet but powerful. This universe was not empty. It was not meaningless. It was active, creative, capable. The last light marks the end of change, but it also marks the completion of a process that began with possibility. Right now, you exist inside that process, inside the era of light, inside the window where questions can be asked. And understanding that does not make the universe feel colder. It makes it feel clearer. If you found this exploration meaningful, consider leaving a comment or liking the video. It helps this channel continue creating long-form science explanations like this one. And if you'd like more deep, calm explorations of the universe, the brain, and reality itself, you're welcome to subscribe. This has been Science for Sleep. And this was the story of the last light the universe will ever make.